Hello everyone. In this lecture we are going to learn about the concepts of streamlines, pathlines and streaklines in fluid mechanics. Here you can see a velocity field or a flow field. You see those larger dashes that remain in their places but just keep rotating at their own places. So those represent the flow field at that point. So their orientation represents the velocity direction. Now, a streamline, by definition, is a curve that is tangent to the velocity of flow at any point at any given instant of time. So, if we are going to draw a curve, theoretically, which is tangential to these velocity vectors at their respective locations, then we are going to get the dashed lines that are drawn, that they are moving, the dashed lines with closer spacings, that is. So those are the streamlines. That means at any given moment, the flow is going to take place along that streamline. By definition, it is tangential to the velocity, and therefore it means that the component of velocity across a streamline, that is perpendicular to the streamline, is 0. The next concept is called pathline. You see the red colored line? It is tracking a particle, a particular fluid particle, when it is flowing through this flow field. That means you are simply drawing its path, so that is called a path line. So it's the path traced by a fluid particle in a flow field. It is the travel history of a particle, and it remains the same regardless of the fluid flow being steady or unsteady. So once a path is taken by a particle, it's written in history, so it doesn't change. Now let's come to another concept of streak line. The streak line here is the blue line. The blue line, you see, it looks like it's tracking a particle, but it's not. The blue line at any given instant represents all the particles at that instant which have passed through the origin, that is the 0, 0 mark. Okay. So it is the line or curve obtained by joining the instantaneous positions of all the fluid particles passing through a fixed point. It's easier to understand with an example. So the example would be a line of smoke from an incense stick. So in this picture, if I take this line of smoke, it represents all the particles of smoke originating from this particular point. If I take the picture 1 second later, this line is not going to be here. It may shift maybe here. So in that case, that is the streak line. But by definition, it still remains the line joining all the particles originating from or passing through one particular flow point in the flow field, that is, in this example, this point. In steady flow, streamlines, pathlines and streaklines coincide because the flow doesn't change with time. So if you go back to this particular figure, you'll not see any kind of change here. The only change you'll see is the path line being longer and longer because any particle is traveling longer and longer distance. But the streamlines and streaklines will remain at their own places. In unsteady flow, streamlines and streaklines vary with time, but a path line it doesn't change. It's history. Path lines do not change with time because they do not represent instantaneous positions of particles, but rather presents the historical path. Okay. There's another concept called stream tube. It is an imaginary tube whose wall is comprised of streamlines. What does it mean? Let's try to understand. It can be formed by taking a closed curve in a flow field and drawing streamlines through all the points in the curve. So let's imagine flow is taking place in a certain flow field. We're taking some imaginary closed curve like this. It can be a circular curve or it can be any kind of arbitrary shape, but it needs to be closed. Then from each of these points, if we draw streamlines, then it will give us a stream tube. This concept is sometimes necessary for assumption of control volume, where we don't want any kind of inflow or outflow from a particular control volume. And that's because flow cannot occur across the walls of a stream tube, because by definition again, flow cannot take place across a streamline, and in this case a stream tube is made of streamlines, so flow cannot occur in or out of the stream tube except for the inlet surface and the outlet surface. So this is all for this video. Thanks for listening.